So we're going to go over the APBC MacLaurin quiz. That's actually Taylor Polynomial quiz, technically. This is a Taylor polynomial centered at x equals 0, right? So we're going to write the MacLaurin polynomial of degree 3 denoted p3 of x for each of the following functions. So then I give you a bunch of functions, right? Okay, so number 1, we're asked to do sine of f of x, right? So it's worth noting, right, that you hopefully have the sine series memorized, right? So sine of x is essentially all the odd powers of x over the factorial of that power, right? So like x, right? And then it alternates. So minus an x cubed over 3 factorial plus an x to the 5th over 5 factorial plus da-da-da-da-da, right? Cool. So when I want to do sine of 5x, all I'm going to do is replace every x I see with a 5. X, my bad, sorry. Brain sometimes checks out. So since I want p sub 3, it doesn't mean the first 3 terms, right? This means up to the x to the 3rd term. So although I wrote more than that here, all I have to write here is 5x, right, minus this 5x quantity to the 3rd over 3 factorial, and that's it. Now, you might want to clean it up a little, especially if you're going to have to use it. You're going to get a 5x minus a 125x cubed over, and you could leave it as a 3 factorial, you could make it a 6, that's fine. Okay, so a couple things to note here. There's no dot 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 at the end because it's not an infinite series. It only goes up to the x to the 3rd term because it's p sub 3. It's not the 3rd term, it's the x to the 3rd term, right? So like whichever one has an x to this power, right? All right, second one, right? The second one I'm doing is natural log of 1 plus a 3x, right? So if you have memorized the natural log of the quantity 1 plus x, that's super duper awesome and congrats, you're great, right? And totally great of you. If you don't, that's also okay, right? So this is an x minus an x squared over 2 plus an x cubed over 3 plus da-da-da-da. I can never remember this to save my life, though. So instead, what my brain always does is my tragic brain, has never ever managed to memorize the natural log of the quantity 1 plus x. Instead, I always memorize this guy because I recognize that this is actually geometric, right? A over 1 minus r, it's geometric where a is 1 and my r is a negative x. So I know that this guy is the series a times that r, which would be a negative x, times the r again, which would be this, times the r again, and so on, right? And then I recognize that if I were to integrate this with respect to x, I'd get this. So that's what my brain was doing when I was hemming and hawing and trying to think of it. Anyway, so if you have the series for a natural log of 1 plus x memorized, that's awesome, and you probably should. If you don't, you could do what I did, figure it, like know this one and then integrate. Anyway, point being, I have this. What I'm then going to do is anywhere I see an x, I'm going to replace it with a 3x. I'm only going to go up to the 3rd term, right? So I'm going to get that my p sub 3, let me erase some of this useless nonsense about my brain. I'm going to get that my p sub 3 of x is going to be, instead of an x, I put a 3x, right? Minus, inside that squared, I'm going to put a 3x, right? Make sure that the 3 is also getting squared, and that's over 2. Plus, inside that cubed, I'm going to put a 3x, and there you go, right? So what you're more likely to see this as is a 3x minus a 9x squared over 2, or a 9 halves x squared, right? Plus a 27 thirds, or you can make that a 9x cubed, right? So probably the most likely answer to this is 3 minus 3x, mea culpa, 3x, minus 9 halves x squared, plus 9x cubed. Cool. All right, let's talk about number 3. All right, so number 3 is x squared e to the x, right? So number 3, we're given x squared e to the x. So you want to know the e to the x series, right? It's the x to the n over n factorial, and they're all positive. It starts with a 1 plus an x plus x squared over 2 factorial plus x cubed over 3 factorial plus da-da-da-da-da forever, okay? So knowing that, what I'm doing is I'm taking this thing that goes on forever, and I'm plugging it in here. So I'm basically just distributing an x squared to this. So my p sub 3 of x, if you put an x squared in front of this whole thing, you'd get an x squared times 1, right? And then you'd get an x squared times x, which is an x cubed, and then you would stop because this says, oh, hey, only go up to the 3rd power, and that's it. That's the 3rd power. Now, if I'd asked you to write the first 4 non-zero terms, or if I say write, instead of a Taylor polynomial, if I ask you to write the infinite series, well, then you're going to have to keep going, and I might ask you for the nth term, etc. But in this particular quiz, I only wanted p sub 3 of x. All right, cool. Last one is the challenge. We're going to keep that e to the x because it's going to matter in the last one. So the last one's a little tricky. It is an x plus 2 times an e to the x, right? So the thing is that what I need to do is I need to multiply, I only want to go up to the 3rd degree term, right? So I'm essentially multiplying each one of these terms, right, by this guy, by the x plus 2. So I'm going to do the x plus 2 times the 1, and the x plus 2 times the x, and the x plus 2 times the x squared, right? But when I get to the x plus 3, the x plus 2 times the x cubed plus 3 factorial, I don't actually want both terms, because one of those is going to come out as a 4th term, right? So really what's happening is you're foiling, or you're distributing, but not every single term is going to count. You might want to do a spot where you put a little bit of work, right? So one option is to do some work and say, hey, I get it. I'm going to take this guy, and I'm going to distribute to this, right? There's no reason, since I only went up to the x cubed term, there's no reason to write anything after this. Because I know that x times x cubed over 3 factorial is already too big, but 2 times x cubed over 3 factorial is still an x cubed. So I'm going to go ahead and distribute. And one way to think about this, right? So you could either do this as work, or honestly, if you wanted to, you could be a little lazier. I'm going to be lazier. I'm going to recognize that I take this x, but I can only multiply him by these first 3 terms. It's going to be x times the terms that would yield something smaller than a cube. So 1 plus x squared over 2, right? Plus the 2 times, now the 2 can get multiplied by all of these because that'll go up to an x cubed as well. So 1 plus x squared over 2 plus x cubed over 6. So what's going to happen is my p sub 3 of x is going to end up being an x plus an x squared plus an x cubed over 2, my bad. Cool, so this guy's done. And then I'm going to distribute the 2. And notice I'm kind of lazy, so I write things where they line up. So I'm going to have a 2, right, 2 times 1, plus a 2x, because 2 times x, plus what seems to be another x squared, right, because the 2 times the x squared over 2, right, plus a 2/6, which you can leave as 2/6 if you want, to be honest, because you're going to need it in a sec anyway. 2/6 x cubed, and that's all of my cubes, right? So now I combine my terms, right? If I combine my like terms, I get a 2 as the constant, I get a 3x, I get a 2x squared, and then when I clean these guys up, the reason I left it as a 2 over 6 is I realized the common denominator between, even if I canceled it and made it over 3, the common denominator would be a 6. So this is a 3x cubed over 6 plus a 2x cubed over 6, so I get that this is a 5/6 x cubed. And that is my p sub 3 of x. So that is MacLaurin quiz number 2.